Okay. Björn, would you like to introduce yourself before we get on to the questions?
Yeah, I can say a couple of words. I initially was supposed to give a talk, but I was so busy scaling stuff that I couldn't prepare a presentation, and at the last moment I was offered to be on the panel anyway, and accepted. Very briefly about me, I've been writing code for 35 years, approximately. I'm 44 years old, so you can see that I started early. The workflow has changed very significantly over that time. When I started writing, programs were distributed as listings in magazines, and I worked with my father. I could read, my father could type, and the micro-B computer could do a checksum on the code so that we knew that we had replicated the program listing correctly. So that's how I started out. For a brief period, I went into physics instead. So I did a master in engineering physics, but have always been attracted to computer science, computation in the abstract as well as the concrete. So after that, I actually ended up here in Helsingborg, where I briefly worked for a company called Warthog and did physics simulations. And after that, briefly in London for Sony Computer Entertainment. After that, for a quite long period for Ericsson in Lund. And there the workflow was very different compared to today, which I find quite interesting. I mean, there are two ways to think about scale, right? You can think about it as scaling organization or scaling like architecture code. And actually, like the scale for me in terms of organization has gone down over my career. So the largest scale I've seen in that sense was Ericsson, where we were like 5,000 people working on a code base that went into a single monolith. And we didn't have TDD, right? We had test cases. Like I led a project that had 2,000 test cases, but we wrote code for 2 years, and we couldn't even link it because the linker didn't work in the SDK. And then when we were done with all the code, everything was complete, and we had it reviewed and merged in 13 different modules spread over 4 different departments. Then we ran the test cases. That's how you worked back then. So a lot has improved to the better since then. And I think now my model of scale is like I like small teams working autonomously, CI/CD, TDD to some extent. Haven't absorbed that fully. And I'm much more interested in the other side of scale, which I would say is when your code is complete, can you run it at any scale? Can you scale it to any level, so to speak? And at Sinch, I've been responsible, for instance, for a system that processes 1 billion events per day and keeps track of approximately 1 billion Swedish crowns every month. And if you go back 20 years, then that would just have been impossible, I would say. So, yep, briefly.
Thank you. One brief thing before I get to the questions. A couple of people have noted that the slides were a little bit washed out. I apologize for that. The monitor that was originally back here broke last night, and we had to replace it with the projector. And unfortunately, none of the presenters got a chance to test their slides on the new projection technology. But the recordings will be available after this. All of this is being recorded as well as streamed. So we'll make sure that it's available to everybody if you want to go back and look at the code examples and such. Okay, who had the questions? Yeah.
Hi, I will be the voice for online questions. So I think the first question is directed to specifically Geoffrey. Hi, about code at scale. How many engineers proportionally are dedicated to maintaining and developing the tools and process for these 100,000 plus engineers to use?
Oh, that's interesting. So there's a couple of different things that we have. So Google had people who were developing the core technologies like code search and the Piper monolithic repository, like all the stuff that made the basic stuff work. But then we also had people who were dedicated that they called engineers for productivity, so EngProd. And those people were trained to help individual teams to automate stuff, to figure out how to become more productive as the individual engineers. So we had groups that were dedicated to the big problems, the getting the compilers, doing the latest technologies for like squeezing. You know, when you squeeze out 1% of performance in your compilers, and you multiply that across 1 million hosts, that actually adds up to quite a bit of money that gets saved and a lot more efficiency there. So that broad team that handled the tools for users was quite large. I think a few hundred people that were dedicated to compilers, code technology, the caching systems, the file systems that were used for doing that layered the layered checkouts where only your local changes were done locally and everything else was remote. All of that stuff is several hundred people. And then the EngProd folks were distributed amongst the teams. So I don't actually have a number off the top of my head. They often went to the teams that were saying, you know, where the director was like, I've got 100 people, but I'm only getting like 50 people worth of productivity out of it. What am I doing wrong? And so they would dive in like with 1 or 2 people per larger team. Sometimes you'd even get a project that had, you know, 100 engineers doing the main development. Then you would have, you know, 2 to 4 of the EngProd people helping to get everybody efficient. And then you'd have a few other people who are doing things like looking at particular problems, reliability problems, and so on and so forth. And by the way, just as a side note, if you end up having EngProd people in your organization, it's not their job to write your tests. I just want to say this because it comes up all the time where people are like, yay, we don't have to write tests anymore. Well, as he said, you want to actually have the developers writing the tests, and you don't want to export that to a different group. There is some usefulness to having people writing integration tests that are separate. Those are called acceptance tests, to test separately whether a customer can use the product. But the unit tests and the internal integration tests, you want those done by the developers, and you want the EngProd people actually looking at overall productivity, not just, you know, like make my tests run a little faster.
Does it work? Yeah.
Yeah.
So can't we hope it was the answer for you? Jans asked a question about event sourcing. Is there any examples of event sourcing in practice that you recommend to look closer at using Azure and Net if possible?
Good question. Good question. The problem is there's a lot of examples, but the actual real life code, the actual code that is being used in production at companies is the best example. Except that the companies that produce that code are not so eager to put all of that online. I don't know why. So there's a lot of examples that they then distill from that, but they become very bad examples because they're distilled and they're not showing the actual problem being solved. I guess I'm trying to make the answer really long just to say no. It is really, I mean, we've been working on sample applications and just samples of showing, but the real example is just to start from the beginning, start the process, and then building it out. There's no end result you can show, say, hey, this is a good example of how to do it. It's more about the process, how you get to that actual code than the end result. It's a bit of have you ever walked into a meeting or into a meeting room, and then the meeting prior to you, they didn't clean the whiteboard, right? And there's this diagram on it. sometimes they look really interesting, and sometimes they look extremely wrong. But if you try to make sense of it, it doesn't make sense, because it's just the end result of probably an hour-long discussion of people, and the value is in that discussion, is in that process of getting the end result, and that's something you will not really get from any, not even conference talks or whatsoever, is to just experience it, go for it, try it.
So Jens, it's all up to you.
Good luck, man.
So we have a last question. When would you choose event-driving design versus direct queries between services? Any general advice?
Long answer short, never. Always. I mean, if you do direct access from one service to another, no matter, and it depends a bit on what direct access means. If it's really poking into the code, then don't. If it's doing HTTP calls or direct RPC calls, I would say try to refrain from that, because it gets you more stuck than you probably anticipated. Having that message-driven indirection is something that we've learned over the past, well, I guess it's a learning experience of about 15 years of event sourcing and CQRS combined, that we've learned that is the single aspect that gives you the most advantage. So forget about domain-driven design, CQRS, you can forget about that. If you get your messaging right, that's where the boundaries of components in your system hit each other. Make sure you get that right. Spend time there to design that properly, and then you'll be able to change the internals. So I would say just refrain from direct access if possible. Yeah.
Thank you. We are done with online questions.
Great. So I had actually a question for our guest here. I had a chance to talk about some of the automation that was required for Google to be able to get anything done. And Eric, on the other end, was talking about what does a small startup have to get anything done. I'm kind of curious, you've worked at some sort of mid-range companies of various types. What was automation like in that middle range? For what were you getting the most advantage from? What kind of things did you want to work on first? How did you make the decision of what things get automated, all that sort of stuff?
Yeah, I've seen quite different environments there, even in the mid-range. I mean, the mid-range is very heterogeneous too, right? So I've founded a startup that architected and developed a radio access network system, and later licensed it to Ericsson Networks, among others. And there we were like 5 engineers, very, very highly skilled engineers. But actually we did not go with a mono repo. So even with like 5 engineers, we decided that the mono repo would not be scalable. I guess the sort of main automation we did there that really contributed was that we had a software component that needed to go into very close to the radios, and those radios were integrated with chipsets in like Wi-Fi routers and stuff. And the architectures were completely different and so forth, and different compilers and everything. So like initially we did this ad hoc, but then at some point we gave up and we just built like 400 combinations of compiler, Linux kernel, C library, and like every combination. And I think it turned out to be like 400 binaries that we made available to our customers. And I guess that Sinch is very different. Sinch is like, has grown from about 700 people a year to 4,000 people approximately in about a year, and through acquisitions. And that's not engineers though, that's like employees, but quite significant growth, and also through acquisition, which is very tough from a social point of view. You have a lot of different cultures coming in, and you want to integrate into a totality. I guess the automation I see there that really moves the needle is probably around like DevOps stuff. So there are some initiatives that I think are very promising where, yet again, it has to do with that monorepo, multi-repo thing. I think that you know, I'm seeing a hybrid that I think is very interesting, where there's like the platform is a monorepo, and some very, very sort of slow-moving, very, very sort of engineering heavy stuff is in the monorepo. But all the teams working on customer-facing stuff have their own repos and their own CI/CD, and they can deploy independently of each other. And you can have like 100 teams working very, very quickly, iteratively, as if they were their own little startups. And you still have this platform that you can sell to an enterprise customer as a single platform, so to speak, which I find very interesting.
Actually, I'm curious, given the way you just said, Eric, from your point of view, you had said you were hiring and you're looking to be adding more people. Is that, would you consider doing the kind of thing that he was talking about, of saying like, okay, some of the people are going to be working on the platform, some of the people are going to be working on individual projects? Or do you think that as you grow from that tiny size to slightly larger, that you want to maintain the same structure to your code base that you had originally?
I think that for now, at least, we would continue using the same structure on the code base. And I think that the whole idea of microservices for me kind of becomes a maintainability thing as well. That you can kind of say that, well, these are chunks that can operate individually. So as we continue hiring people, you can actually say, this is your responsibility. You can continue working on these services together with the rest of the system, of course. But I think that to some extent, my hope at least is that I should be able to continue using the same kind of architecture. But I also imagine that it's maybe not going to be as important to be as on point on all the automations and on the homogeneity of the code bases and so on. Because we do that because we just simply can't afford to spend time on those things.
Yeah.
So I have a feeling that the more you can afford to spend time on those things, the more you might actually relax that kind of thing as well, regardless if you want it or not.
Before we go on for any more panel discussion, did anybody in the audience have any questions? Because we dealt with the ones that were online. Yeah.
So my question is for you, Eric and Allard. Different kinds of systems, but it's the same question. And you did blue-green deployments, Eric, if I heard it correctly, which means you have two versions of your app running at the same time. And for me, like once per decade or so, I make a mistake and I want to change my data model. And sometimes you have a dependency that both versions may be using the same column in a database or some other thing. How do you handle that case? Doing a migration and one release and doing another migration and removing, and so you're using two versions of the app, but the same data model, and you have to migrate it. How do you handle it? And the same question, how do you handle it when you evolve the event-sourced models? It's a tough problem.
But it's only once in a decade, right? So still manageable.
We don't. I think that when it comes to data model, the way we think of blue-green deployment in our sense is simply that we have one app going up and then switching over to that app after some stability time, and then we shut the other one down, basically. So just to minimize downtime. So that only really happens during deployments for us. Of course, we could still have multiple versions of that app running because it could scale up using a scaling trigger of some kind, and we could have 2 or 3 or even more of a specific service. And they do use one database together, of course. One service uses one database. However, those are only really read models, so they're not the point of truth for us. So for the most part, what we can do is, depending on how big that change is. Of course, we can just restart all of our instances, and they will simply run migrations on startup. Those migrations, it might sometimes, depending on how big the change is, even mean that we might actually have to basically delete and rerun all our events for that one single service, which we do every now and then. So it's even if we have fairly big changes, it's not really the end of the world. We can just kind of kill the whole database and rerun it because we have the events. So we just replay all the events and then we have the data model again.
And I think that's also key to the answer I was preparing in my head. So thanks for just what he said. The thing is that most of our customers and users of the open source versions of our product, they use CQRS, right? Meaning that the side of the application that processes commands is separate from the side that provides information about the current state. So on that command side, very often, I would say in the by far majority of cases, they use event sourcing, where you don't have that problem of sharing the data. You just have your events describing what happened. So sharing data might be something you have on the projection side, where once every 10 years you make that call where you say, no, it's two UIs that use the same projection of basically use the same data, but then eventually you discover, wait a minute, they're not really the same. They need to be split. And that's literally the thing you can do. You can start to split that data, and now you need to project the events that happened onto what does that mean for these data sets now separately, right? Obviously, there's a reason you want to separate them, so there must be a difference in processing of the two. And then you can continue from there. And it's either continuing from there or finding out that, oh, I should have known this 9 years ago. So we've been doing it wrong for 9 years. Let's go back in time. Let's throw away the database and just rebuild it. And that's.
I think the way we've seen it is that as long as we have the events, we have an unlimited number of attempts to get it right.
Next question in the back there.
Hello. Sorry, just
sorry.
Follow up there. But a couple of years in, you have a large database with a lot of events, and then you figure out that you want to evolve the events, the structure of the events. So 10 years from now, you want to replay, and then you have version 1 of the event and version 2 or version 3. So how do you keep all these versions and replay how do you handle the case?
So there's a construct in event sourcing called upcasters, and an upcaster is basically the implementation of how you change your mind over time. And the thing is that because the upcasters, they can be applied, they're basically a processor that takes an event as you thought it was good 10 years ago and translate that to what the structure of the event is next. And you can chain those, right? And if you get to the end of the upcaster, you'll get the structure of the event as you see it nowadays. And that way you can store the events as they were, so you don't need to change anything in the event store, which is something that especially auditors, they love. If you have a append-only store and you cannot manipulate any data. But the events you need to deal with in code or in the current situation is only the latest formats. So these upcasters is literally just one session of I changed my mind, right? You implement that, you put it, I always say, put that in a dark corner of your repositories, write it, configure it so that the computer knows about it, and then all you humans forget about it, right? It does not exist. It is there in a corner. Hopefully you've got some automated tests to make sure they keep on working and they keep on being configured, but at least from your mental model, they're gone, right? You don't have to worry about them anymore. And there's a lot you can fix with upcasters. Not everything, but yeah.
Yeah, so I guess my question applies a little bit to the previous question in that if you don't have an event sourcing, but you want to go there, but you have a decade of data in a different format, how do you start going towards that? And also, if you have a monolith that isn't message driven in the same way? How do you start that process?
I'm not sure I can answer that in a quick way, actually. I think that, yeah, sorry.
How does a man move a mountain?
Yeah, exactly. It's that's actually a very tough one, because for me, it sounds like two very different architectures. So I think there's a certain danger in trying to get it to fit into the existing one. I mean, the only thing I can think of is just trying to find that minimum use case where you can start applying it and just building one single thing event sourced. But I think that's the best answer I can give, at least. I don't know if you might have a better one.
I've seen some cases where it was successful in retrofitting. The big problem is that you don't have history anymore, right? You just have the current state. But as you saw in my slides, if you recall the order, and on the left you had this little history, and on the right you did not have as much history, but you can still distill a bit of history from that, because you know to be in that state, the minimum you have to have done is create an order, add one item, ship it, and then wait for the return shipment. So you can reproduce a bit of history based on that. And that's something we've done in actually one of my very first event sourcing systems, which was a rewrite of a monolith in which a relatively small, extremely small number of developers had produced a big ball of mud in a mind-blowing little amount of time. That was an engineering achievement in itself. And who got to wear gloves to clean up the mess? It was good fun. It was a really nice project. But we had to retrofit the history, right? And we made some really beautiful mistakes in that process. So if you want to learn about the pitfalls, I have a few for you. But it is possible to get a bit of that of that history. In most systems, however, that's going to be really difficult. And in that case, there's a pattern called the strangler pattern that you can use to take a monolith, and it's named after the strangler fig, which is a kind of plant that grows around trees, and ultimately it just feeds off the tree, and the tree dies, and then that plant remains. And that's what you can do with a monolith too. You can strangle it by creating smaller components that take away the functionality of the monolith, implement that in a different way. You still have a way to link back any decisions, because the monolith still needs to breathe for a while. And then ultimately either the monolith dies off and you, or it's that COBOL-based systems that you will never be able to really get rid of, but you keep the minimal set of logic in there. So those are roughly two approaches you can take to get this done. But it really depends on how far the decay in the monolith has gone, because we get that question a lot. Hey, can you help us take our monolith and make it a beautiful structured modular list? And I always say, well, we'll know in hindsight if that can be done. 50% chance.
So I've got one thing to add there, which is that some companies, there isn't one monolith that you're needing to move, there's dozens. I worked at a company, and they shall remain nameless for their own health. They had, over the years, had decided how they wanted to change their customer and order systems, like the common things that are used as examples, except they never turned off the old ones. So what had happened over the years is that they had built up more and more things that were sort of the source of truth for some particular time window. And there was a whole bunch of middleware whose job was to try and kind of keep these things equivalent. At one point, they had 14 different definitions of what an address was, which was really quite a horrible thing. And I think one thing that you have to look for is that if you're going into a project, going into an existing situation where there's a lot of existing code, you may actually have to have a phase of going like, can we partially clean up what's there before we even create the new one, because you don't want to keep chaining that on. And you also don't want to find out that all those data sources you had are in conflict. right? So you have things that had slightly overlapping times because, of course, there's a time period where they're saying we're going to ramp up the new one while we're ramping down the old one. They've both got copies of the data that, the events that happened during that time period. So you'll see data that is not the same between the two systems because, of course, they saw things differently. So that becomes an issue as well. Sorry.
Yeah, I was also thinking like if you could could you append on an event sourcing on top of continue on new things going in event sourcing but keeping the old stuff? But I guess it ties in a little bit that you get a little many things never turning off.
Well, I mean, what he was saying of this the strangler pattern, you have to let the tree get strangled at some point, right? You can surround the tree and have everybody else talking to the new stuff, but at some point that tree has to go away. Is my particular feeling. There is the question that he brought up of, do auditors have a say in that sort of thing? I saw the far end of the trouble where it was the auditors would have said that the original was not auditable in the first place. But it is something where you have to be careful not to just have nested layers. Like you can have a strangler of a strangler of a strangler. That's bad.
Yeah, and I think it needs to be a very conscious decision to let it die as well. It's not something that will happen on its own.
Right.
And I think I've seen in a lot of code bases where you've basically patched something by adding another layer on top of it and tried to replace some existing functionality, and the other one is just supposed to be there for a while. And then, oh, right, we have these dependencies too, so we can't really kill it off. So let's just leave it and not touch it for several years. And then we realize that what we just built, maybe that's not perfect, so we'll add another thing, and then you just go on and continue like this, and all of a sudden you have 5 legacy systems all talking to each other in weird ways. So you really need to have that extra effort to make sure that you shut things down and remove them.
And this is a classic, right? It doesn't only apply to event sourcing or anything else. We jokingly talk about it at Sinch as rebuilding a Boeing 747 while it's in flight.
Yeah.
You can't land, but you want an entirely different plane. It's a challenge.
Yeah. Yes. Yeah. And if you're designing the engines at the same time that you're rebuilding them, that's also an issue. Time check. I think we're getting close. Okay. Do we have time for one question from the remote? Yeah.
Thank you. In name of Frederick, the question is on event-driven microservices. So if you got does it work? Yeah. If you got a couple of services communicating through direct REST API calls, otherwise independent of each other, what would be the first step to evolve to a better architecture?
I would say, does it work? Do something else. If it works, it works, right? Making a change for the change, making impact because you just want to make impact is not the thing you'd want to do. So apparently, if there's a need for change, there's something not working. And if it's because of that direct communication, for example, because you want to be able to do load balancing slightly different. And I said the commands and queries have different routing patterns where very often queries are just, I have a question, I need information. If there's 5 components, 5 instances of a component, whichever of those 5 is going to answer my question doesn't really matter that much, right? I can just get the answer and get it done with. But when you're executing a command, which is typically a change, then sending several changes, for example, for the same order, right, for the same aggregate, for the same instance, and sending those to different machines, that will very likely cause a problem somewhere. You'll get conflicting decisions being made. So decisions about the same consistent state are made on 2 different machines. They will bump into each other at some point. Right? Hopefully, you have optimistic locking to detect that. So in that case, you want to use that routing, and if that is quite difficult to do on a load balancer, for example, with HTTP calls. So if that's the kind of problem you're hitting into, then I would say just build a little abstraction layer before doing the HTTP call make that a message first and have that message execute the HTTP call. That's step one. Then you'll have message. Do something similar on the other side, and then think about, okay, now how do we connect the messages directly, not through an HTTP call, but through some other mechanism. So it's about getting the indirection in first, and then changing the implementation. And you can do that in flight, Boeing, Airbus, doesn't really matter. That could be an approach, but it really has to make sense, because it takes a couple of deployments to make it work.
Great. We have one last question to Eric. We can keep the answers simple, maybe. I think we don't have too much time. Yeah. So you mentioned game development. How does TDD relate to highly agile products like games, where the entire features and systems might be scrapped on a weekly basis? Is the time spent on writing tests still justified? And when, if ever, do you write E2E tests for them?
It's definitely justified. I think we had 1,200 unit tests for the engine alone, but we also didn't scrap our systems on a weekly basis, to be honest. But it also depends on what kind of tests you're talking about, because you end up testing a lot of infrastructure stuff. So that's the stuff that keeps on changing and is usually smaller things, such as just scripts that. For instance, we had a lot of scripts where you had just an update loop and a main function, basically. We usually didn't test that, but we tested all the systems around it, like state machines and everything that hooked into those scripts. So yeah, I think that you end up writing unit tests towards the system and the framework around things, rather than the actual, rather than the actual game logic. But there is a balance.
All right, thank you. I want to thank the panelists and morning speakers.